So in 7.3.21, we have a coin, and the person doesn't know what the probability of the coin is, but let's say someone in the universe knows the probability of this coin is 0.63 for heads. So this is our true probability. Now, your researcher is going to toss the coin 300 times to estimate P. So he's going to have N equals 300. And he's trying to find P hat for whatever sample is, and he will use that to estimate the population proportion, P, or the true probability. So P hat is what he gets in his sample. P is for the true population or the true probability for all time. So what would be the probability that his sample proportion will be between 0.62 to 0.64? So remember, every different sample he gets will give him a slightly different sample proportion. That's the whole point of sampling distributions, is what are the possible sample proportions we can get. Now we want to find this probability. We've learned about the continuity correction. So the continuity correction is always better if you are working with a discrete distribution. So tossing coins, heads, you're counting of heads, tails, heads, tails, so that's discrete. The continuity correction just makes it a little bit better. So to use your continuity correction, you have to switch to counts. Because we haven't figured out a continuity correction that counts that works for proportions. So we were trying to find the probability that P hat is between 0.62 and 0.64. But we're going to have to switch that to counts instead. So let's change these probabilities to counts. So 0.62, a count of that, if he gets 62% heads, that would be 0.62 times his 300, which gives me 186. And 0.64, switching that to a count, would be 0.64 times 300, which equals 192. So really now, instead of proportions, we're finding now what's the probability that he gets between 186 and 192 heads. So this is now our count. We're looking for that probability. Okay, now if you want to find probabilities for anything with a normal distribution, and we know our normal distribution can approximate counts and proportions, you have to find your new means and standard deviations. So for counts, you have a new mean, mu with an x for counts, is equal to n times p. So in our case, 300 times the true probability, which is 0.63. So the expected value of heads would be 189. The standard deviation is equal to the square root of n times p times 1 minus p, which is equal to the square root of 300 times 0.63 times 1 minus 0.63, which is 8.36. Okay, so we found our new mean, we found our new standard deviation. That's what you do every time you want to use a normal distribution for any problem. Now we have to standardize. Okay, let's see, before I standardize, I might draw a normal distribution like this. I'm looking for between 186 and 192. Now for continuity correction, you don't have to memorize the formulas for continuity correction, just think about it. Every time you just want to make it half 0.5 bigger, so we'd go this way. So to 185.5, and we go this way to 192.5. So I always make that area 0.5 bigger on both sides. That's what I remember, not the formulas. So z, my first z value, remember, it's always going to be x minus the mean of x over standard deviation of x. So my first x value is 185.5 minus my mean of 189 over 8.36, which is negative 0.419. My second z value, again, we do the x value minus the mean over the standard deviation. So that other x value is 192.5 minus 189 over 8.36, which gives me positive 0.419. Now I finally found my z-values. So negative 0.419 to positive 0.419. So it did take a little while. Notice also that this looks very different than the work in the book. We're doing the exact same thing, but they don't want to write out a lot, and they try and make it as short as possible, and they use a lot of much more confusing notation than you really need if you just kind of write it out and use a few more words. Okay, so we've standardized. Now we can go to the normal table. So if we look up negative 0.419, so negative 0.4, and then 19 would probably just round to that 2. So we're really looking at negative 0.42. So that would be this here. So this 0.3372. But that is only this area right here, 0.3372. So let me just redraw my picture. So we're looking for the area in the middle, but I found this area is 0.3372. Okay. Now look up your positive 0.419 on the next page. So 0.419, this would be the closest, 0.6628. So from here to here is 0.6628. Now to find the area in the middle, you just subtract that. So we'll do 0.6628 minus 0.3372, which gives me 0.3256. So that's my probability. So if I was to write that out, it would probably look like, my final answer would be the probability that p hat was between 0.62 and 0.64. Well, I switched that to counts. So it's the probability that we're between 186 and 192. And when I standardized and used the continuity correction, it was almost equal to the probability that z was between negative 0.419 and 0.419, which I had to change to 0.42 to use the table, which is equal or approximate to 0.3256. Now, the textbook didn't have to use the table, so their answer is just a little bit more accurate, but that's fine. So about a 32% chance that he will get a sample proportion between 62% and 64%.